It is my pleasure to welcome you all to the fifth edition of Smarter Conversations, a thought leadership series by AMNS India, proudly presented by Optigal. At its heart, Smarter Conversations is about insights that build the ideas that inspire. It is about reimagining how engineering and construction can shape a smarter, more sustainable future. Every session brings you perspectives from leaders who have pushed boundaries and turned challenges into opportunities. Today's theme, engineering efficiency, innovative approaches to elevated metro optimization, takes us into a field that is transforming the way our cities move. From designing innovation to executional excellence, metros represent the backbone of modern urban transport, and optimizing them is critical to building resilient infrastructure for tomorrow. Today, we are truly honored to have Mr. Saibaba, one of the most respected voices in India's infrastructure ecosystem. Mr. Saibaba is the ex-chief engineer of Indian Railways and currently serves as the advisor to NHIDCL Tunnel Projects. With over 36 years of experience in mega infrastructure projects across railways, highways, ports, metro systems, and tunnels, his career has been nothing short of remarkable. He has been at the helm of some of the most iconic engineering feats, including the world's tallest rail bridge in Manipur, India's longest rail networks in Northeast, and metro rail projects in Bangalore, Hyderabad, Trivandrum, and Surat. His expertise has also contributed to the international projects in Malaysia, Singapore, Africa, and beyond. A recipient of prestigious recognitions from the Prime Minister's Group Award for Innovative Logistics Planning to the Railways Minister's Gold Medal, the ICI Lifetime Achievement Award, and many more. Mr. Saibaba is also deeply committed to knowledge sharing, having delivered over 660 lectures to young professionals and students. His journey is a testament to innovation, vision, and engineering excellence. It is an absolute privilege to have him with us today. Mr. Saibaba, the virtual stage is yours.
Thank you very much, Muskan, for the nice introduction. I welcome all to this webinar. First of all, it's my honor and duty to thank the organizers, AM and NS, for giving me this opportunity in sharing my experiences in metro rail, having worked in 4 different metro projects, but it's all elevated only which I have worked. So today I'll be talking about some of the innovative measures or optimization measures which we have done in these different metros. So I thank all the persons who have attended and who registered and who have joined this seminar in the late Friday afternoon for participating in this webinar. So this is the topic which I'll be talking on: engineering efficiency, innovative approaches to elevated metro optimization. So I'm confining myself to elevated metro because that is my core strength as far as metro rail is concerned. And I suggest that if you have any questions, you please write that in the question box provided there, so that I can take them in the end of the session. So let me start with the basics, just to have a foundation why a metro is required in cities. We all know that the traffic is tremendously increasing day by day, and the existing roads are straining with the traffic, and there is no scope for increasing or augmenting the capacity. So there is definitely need for MRTs in major cities and also tier 2 cities, which Ministry of Urban Development has already notified. And some of the factors which are required to decide the type of MRTs, because there are different types of MRTs. Metro is one of the options. So we have to evaluate the various options available before deciding on metro, because metro is cost intensive and also takes more time for construction. So I have listed down these factors here: safety and speed, comfort and economy, technical constraints, reaching the masses, mode integration. The different modes like railways are there, then bus service is there, then the MRTS is there. All the 3 modes have to properly integrate with each other so that passengers will have the last mile connectivity. Some of the options which I have identified and which we have studied for the various metros are like this. And if I go a bit in detail, MMTS is somehow popular in Hyderabad, multimodal transport system. But what is happening is, though it has got some advantages of being cheap, because existing railway network is more or less used, existing railway assets are also used. So the additional infrastructure required is not much, and it can carry high capacity. But on the cons side, on the demerit side, we have limitations. MMTS has got fixed corridors. Wherever railway lines are there only generally these MMTS services can be provided. And the preference will be given for trains. If it is a mixed type of traffic where the normal trains are also provided, then MMTS trains will be given less preference. And mode integration is not very much achieved in this type of transportation system. The second option, of course, is the trams, which is popular only in Calcutta in India, but in the European countries, this is a very popular form of transportation. If somebody has visited France or Geneva or Switzerland, it's a very popular system and very efficient system. So it is always better to study the options of tram also. So on the pro side, we have being cheap because it's on the existing road. We lay the tracks. There is no additional infrastructure required. Only rails are to be laid and overhead electrification, if required, has to be laid. And coming to the con side, it is a bit slow and it is unsafe. It occupies the road space and also it is inflexible. The other option, third option, is monorail. It is there in some of the cities in India, like Mumbai, where they found that it is very cheap. It can suit very sharp curves also, and it occupies less space and is good in mode integration because it can be laid on the interior parts of the cities also, where there is the width of land available is less. But the drawbacks or main drawback is capacity is very less. So it cannot take the peak capacity which is demanded by a major city, and it is a bit unsafe. Some accidents have been reported on monorail also, and breakdown has also been noticed and reported, causing high maintenance costs. The fourth option is BRTS, Bus Rapid Transport System. This is also popular. I myself have seen in Ahmedabad. It's very efficient and people are very happily using this service, mainly because it is connecting to the different parts of the city by road, and the connectivity to the other modes is very much feasible and it is very energy efficient. But coming to the con side, this type of luxury cannot be accorded in cities like Hyderabad because it occupies more space. Dedicated lanes are required. You can see here the buses are running happily, but on the right side, the regular traffic is totally congested because they have sacrificed one of the lanes to the BRTS. So unless we have adequate land, this may be suitable for greenfield projects and new corridors, but not for the existing cities. There was a talk about Metro Light, which is some similar to tram, but it has not taken off because its technical feasibility is not found to be still established. So this option also is not feasible. And then metro rail, the pros are it has got a higher capacity. It's a clean and green type of transport system, safe and comfortable because it's fully air conditioned and it is fully elevated or underground with tracks well designed. And the speed also is very high because we can design the system for a maximum of 70 and 80 kmph. But on the on side, on the demerit side, the capital expenditure, capex, is very high, and the time required for construction is high, and even the opex, operational expenses, are also high. The maintenance of all the rolling stock and the assets is going to be high. But overall, we have noticed this. I'm talking in the context of Hyderabad. Overall, we have noticed that yes, metro rail is having a lot of overriding merits compared to the other modes, which I have listed here: speed and reliability, environmental benefits, speed, economic advantages, and urban decongestion. So, because of this, metro rail has been chosen for Hyderabad, apart from the other modes which are already available, and the gauge which is required for the metro gauge. How to decide the gauge? We have broad gauge in India and also meter gauge, which is also called, broad gauge is also called the national gauge because we have 1.25 lakh kilometers of it. So as a common thinker, as a common man, the thinking will be, why can't we go for broad gauge so that we can integrate the metro also into the existing railway network? But the thinking is wrong because the metro rail will be totally having a different corridor, different crowd, different passenger traffic, and different logistics, different frequencies. So broad gauge is not necessarily to be provided. Then what is the gauge to be provided? Overall, if you see the 34 countries in the world, the gauge that is being used for metros is standard gauge, which means that already standard gauge is a proven system. Already the technology is available, the system is available, the equipment and the people who have worked in this type of standard gauge, and the rolling stock and all the other subsystems are readily available off the shelf for standard gauge. So it's a wise decision to go for standard gauge, and that is how all the metros, most of the metros, are now standard gauge. Initially, Delhi Metro, due to some reason, it was having first line was for broad gauge, Calcutta Metro also for broad gauge, but all other metros are for standard gauge, which has got a clear width of 1435 millimeters between the inner faces of the two rails. Other advantage of standard gauge compared to broad gauge is standard gauge being a slimmer gauge, it can negotiate the curves in a much better manner compared to broad gauge. Once we decide the gauge and also the metro rail, the next step is how to take it, whether it should go underground or whether it should go elevated or at grade or at combination. So quickly we'll see the various options and how we evaluated them for Hyderabad Metro. See, underground metro, yeah, it has got some advantages that there is no disturbance on the top, but it is going to be very difficult to construct and maintain. You can see here the cost is almost 2 to 3 times compared to a viaduct. So it is not a viable solution. Moreover, technically also it is not required because the entire area is a Deccan Plateau, very hard strata, and the open foundations will be very suitable for viaduct, reducing the cost, and there is no need for underground. So this has been ruled out for Hyderabad Metro, and at grade, that means both the metro will be at the same grade as the existing road. But here again, we need a lot of space. Like I have explained for a metro rail in the previous slides, a separate dedicated corridor with fenced area, barricaded area is required to run these metros at grade. So this is next to impossible for a major city like Hyderabad, where all the roads are already highly congested and we cannot have any spare capacity for having the metro at grade. So the third option is elevated, and this was found to be most suitable for Hyderabad because the reason that there is no need for underground or at grade. There is a very good rock available at very shallow depths of 4 to 5 meters. They can trap this type of rock material available, so that open foundation can be constructed, which is most suitable for viaducts, and it's also most economical. So finally, for all the 3 corridors, Hyderabad Metro has got 3 corridors, total 70 kilometers. All the 3 corridors have been provided with elevated metros, elevated viaducts. It looks something like this. You see the cross section, it looks like this. The pier is well confined within the median width, and then slowly the flares up and acts as a pier cap on which we have a box girder, and which further flares up to accommodate 2 standard gauge tracks and rolling stock. This is a typical arrangement which has been followed for Hyderabad Metro. Critical issues specific to elevated metro, because metros are generally constructed well within the city. There are some issues which need to be addressed properly. There's a lot of noise, a lot of vibration and pollution which is generated due to construction activity, so which has to be minimized. We have followed the international safety norms to minimize this, and we had a team of experts from different backgrounds who monitor these activities, and we also ensured that the working is mostly during night times where the traffic is less and the progress can be better. Restricted space. We have to work, as I said, well within the width of way given to us, and this is forcing us to innovate the activities. So fast track construction is one important innovation which we have developed here, which comprises of precasting and mechanized launching. And we also have ensured that the site activities are minimized, except the foundation and the pier. All the activities are done with machines and with least manpower intervention. Road traffic control. In spite of minimizing the space required for construction, there are some road diversions required, road controlling required, traffic controlling required. So we used to regularly coordinate with the traffic department and the police department, the home department, and ensure that the proper barricades and signages are provided. And when we work during night time, proper lighting is also provided. The noise and vibration, again, as I said, we have followed international standards, and it is properly assessed by keeping some instruments, and whenever it is going beyond limits, the control measures, as suggested by the experts, is introduced so that the local people, the people in the road traffic and the general public, they are not disturbed much. I will talk a bit about the systems in metro. So systems is like departments in a government department or in a private department. We have different departments. So here in metro, we call them systems. So some of these systems are STC, that is Signaling and Telecommunication System. Then rolling stock, AFC stands for Automatic Fare Collection. O&M, Operation and Maintenance. These are the non-civil engineering. And we have, for civil engineering, we have viaduct system and the yard system, depots, the track system. And then electrical department, we have overhead traction power supply department. Briefly, I'll explain what is the type of system which has been provided in Hyderabad Metro. The communication-based train control system, which is the latest in the world, has been provided here. So the advantages are there are no need of signals. Of course, signals are provided as a second level of defense, and onboard computers are there which controls the trains. And the trains can communicate with each other. They can talk to each other. If they come very close, then one of the trains on the back will be braking or stopping or slowing down. So the end result is we can run more trains at less intervals. That means more frequent trains. So this is the principle of CBTC. The first train can communicate with the following train and accordingly control its speed, which means that the entire block system, if somebody knows about the block system, we call this a moving block, concept of moving block. And the whole operations are controlled in a central location, which is called the Operation Control Center, where people will be continuously monitoring the movements of the trains. Rolling stock. Rolling stock comprises of the passenger coaches or cars, as we call them. And they have got the dynamic air conditioning system. That means the air condition gets itself controlled depending on the number of passengers inside. And 3 cars can hold total 960 passengers, including sitting and standing. It has got one important feature of regenerative braking. That means when the train is braking, applying the brakes, then the energy which is released due to the braking is converted into electricity and fed back into the system. So a lot of energy is again generated and fed back into the system, by which the efficiency of the system, whole system, is increasing. This is the rolling stock which has been adopted finally. This is the cabin of the pilot, which is fully equipped. The pilot's role is just to open and close the doors. He has no control on the train as such, because as I said, the onboard computers in consultation with the OCC will be controlling the trains. Some of the features inside the rolling stock, it has got disabled friendly features also, and dynamic maps, which gives an indication what is the next station coming and what is the duration. And when new drivers are inducted, new pilots are inducted, simulators are available for training them. The traction means the energy, how the train receives the energy for running. There are 2 systems in metro. One is the overhead electric traction, and the other one is the third rail. So overhead electric is the most common one, which is similar to the Indian Railways electrification system. The electric wires are on the top, connected by masts at regular intervals. Whereas in the third rail, there are no masts, but a third rail, as they call it. It is there adjacent to the railway track, and the pushers are there which collect the electricity from the third rail, and then that is used for running the motors. So in the Hyderabad Metro, the overhead electrification system was found to be more technically feasible, and that was adopted. Track system, again, we have 2 different systems, ballastless track and ballasted track. Ballastless track, as the name says, there is no ballast and there is no sleeper also, as we see in a railway track. The advantage is the track is directly embedded into the RCC plinths, as a result of which there is no disturbance to the geometry. There's not much of a disturbance to the geometry. It is almost like a fit and forget type of system. But how the ballast is replaced, because ballast provides a resilience. So that is provided with the special HDPE pads and a combination of elastomeric pads under the tracks. Ballasted tracks, yes, that is still used. We have adopted it in the depots, where all the trains will be coming for inspection and maintenance. All the other activities of the rolling stock will be performed. So there we have gone for ballasted track. This is the ballastless track visual which I am showing, which is directly embedded into the RCC plinth. The RCC plinth is in turn integrated to the viaduct top slab. So this system of a ballastless track. And these are the various components. You can see 3 levels of pads are provided to give the resilience. Otherwise, there will be heavy vibrations and the system develops cracks. This is a view of the ballastless track. And this is a ballasted track in the depot. Now, coming to today's main topic, optimization. Why optimization is required in metros, especially because viaducts are something which are highly repetitive. We have the option of deciding the number of spans and repeating the same spans. If it is segmental, then segments also will get repeated. So there is a scope for optimization as the quantity of the items is very much on the higher side. It is in thousands. So even if I can save 1 lakh rupee on one unit, then I can save crores of rupees. That is why optimization is required for elevated metro, because it directly reduces the capital cost and construction timelines. Brief example of why optimization will be helpful in concrete, which is required for this is again for Hyderabad Metro project. Approximate requirement of the various materials. Concrete is 19 lakh cubic meters. So you can understand, even if per cubic meter, if you can save 1,000 rupees, you are going to save huge amount. So innovation and optimization is the key, and this is what has been achieved by doing a lot of innovative measures in the concrete, like adding fly ash and adding manufactured sand. This Hyderabad Metro is the first metro where not even a grain of natural sand has been used. It's all completely manufactured sand. Optimization techniques which we have followed and which fields we have applied is like this: alignment and geometry, material optimization, foundation optimization, and the most important, viaduct design and construction optimization, and life cycle maintenance optimization. I'll briefly talk about each one of them. Alignment and geometry. So curvature has been properly taken care, because existing roads have very sharp curves. We cannot take such sharp curves for not only from safety, but also comfort point of view, and also providing the required super elevations and maintenance. So this has been minimized at the same time to ensure that the required curvature is provided. Then a vertical profile also similarly, we have avoided steep gradients, and the stations are always kept vertical, and also the stations are always on the straight and level alignments. Span arrangements, because the viaduct is all along in the median, so we have the full control of the arrangement of spans, especially on the straight reaches, and we have provided uniform spans to the extent possible so that the standardization can be easily adopted. And super elevation also has been optimized here in Hyderabad. Again, I think this is the first of its kind when it was constructed. I'm talking about 10 years back. The super elevation or the cant provided for the plinth on the curves has been provided as per the simulation studies, duly considering the speeds of the rolling stock. As it approaches the stations, it comes down again, it picks up. So all that has been simulated, and accordingly, the speeds on the various curves are different. Though the design speed of the entire section is 80 kmph, each curve has got its own design speed depending on its location. So this way also we have optimized the material consumption. So the material optimization, we have used high strength concrete so that the sections are minimized. Pre-stressing steel is also used with low relaxation steel. And composite materials, composite steel girders have also been used. And durability enhancers, as I said earlier, fly ash, GGBS, and also manufactured sand have been used. Foundation optimization. Geotech matching is one concept which has been adopted here, where we have grouped the foundations based on the SBC criteria. Pile foundation was very much limited. It's only for the larger spans where we have gone for pile. So there is not much scope for optimization there. And soil improvement, wherever the soil was not to the required standard, especially in the depots, then we have done the soil improvement measures also. And for foundation excavation, we have used the trial pinches and the GPR, ground penetration radars, to ensure that we are not damaging any existing underground utilities. Construction optimization by precasting and pre-assembly and mechanized launching. And the launching girders used are also designed by our own team, and to ensure that it is suiting to the requirement, and also for the curvatures which we are having on the metro rail. We used to get almost 3 spans per week. Balanced cantilever bridges have been used at road junctions, especially where longer spans are required. But at the same time, we cannot take any support from the bottom. So the entire balanced cantilever construction has been done without obstructing the road traffic below, either from traffic point of view or from safety point of view. And of course, for the road over bridges at 2 places like Secunderabad and other location, we have 80 meter span. So we have gone for composite through girder bridges. And for the stations, we have used the spine and wing concept, which was almost a very new and innovative concept, which I'll be explaining to you in the due course. Similarly, for the life cycle maintenance, because the Hyderabad Metro was constructed on BOT basis. So maintenance also is a part of the contract. So optimization of maintenance was also found to be very much necessary, and maintenance has been achieved by ensuring that we have durable material there, which requires minimum maintenance and inspection efforts like durable bearings and expansion joints, and surface treatments, then access provisions so that each and every part can be easily accessed by a person and can be inspected carefully, especially the segmental girders. Joints between the segments ought to be carefully examined, especially at the bottom where the tension is there, to ensure that there is no crack or there's no opening. I will talk about only two systems, viaduct system and station system, where we have done the optimization. The shapes of the pier, we have different shapes of the pier depending on the location, but most of the locations we have adopted the square to fit into the median space available. So it is something like this. The median space is 2 meters. So to the extent possible, we have ensured that it's a 2 meter square pier. If at all more width is required, then we used to make it as a rectangle, but the 2 meters is not compromised because that is the maximum that is allowed. And we have ensured that a crash barrier of 1 meter height is provided all around the pier so that the forces which are coming due to impact of any accidental vehicle will not be directly felt by the pier. It will be absorbed by the crash barrier. And the profile is so selected that the stresses also flow in the same direction. The flaring up of the pier cap and the box girder is an indication of the pier and superstructure profiles from a width of 2 meters almost up to 14 meters at the top has been achieved. Coming to the types of piers, because depending on the location, we need to provide either a straight pier or a normal pier, we call it, or a cantilever pier, where the pier at the top is having a small cantilever on which the segment is supported, or a portal. Sometimes we have special pier like a hammerhead pier, we call it, or a station pier. These are special piers. This is the statistics of the piers. Total, there are 2,600 piers, different types of piers. And the point to note here is normal piers, almost 1,600. So this is where we can optimize the pier section, the pier reinforcement, the design, and the shuttering system. This is just an indication to show how and where the different piers are to be provided. You can see this is the metro which is crossing the road. This is the highway which is crossing the highway going to the median. So here we have portal piers, and here we have cantilever pier, and then it comes back to normal pier. Normal pier looks like this, a cantilever pier looks like this, and then a portal pier. You can see that a limitation is there for the cantilever. If the deck is, the alignment is at the center of the carriageway, then we cannot have a cantilever, we have to go for a portal pier, and it is like this. And coming to the viaducts, there are several options available, and we had to evaluate all the options, not only from the economic point of view, but also from the logistics point of view, how to cast them, how to bring them to the site, how to construct them. So, however, we made a detailed analysis of all the options, and finally, we have adopted the most popular option of box section, trapezoidal box section. Some of the advantages of having a box section, it is a more optimal section, being the entire area is only confined to the periphery, and its torsional stiffness is also very high. And the top width can be varied depending on the requirement. Of course, this is not adopted because metro requires 2 tracks, and we have adopted the straight normal box shape. Advantages of segmental. It is ideal for fast track construction, and we can do the standardization of span, and we can optimize the design and control the geometry in a much easier manner. How to decide the optimal span? Because there are different studies which are to be done before we decide what is the optimal standard span. So these are the various factors which I have listed. Important among these is the RSI studies, that is a rail structure interaction. Due to the rail, the welded rail, LWR rail, we call it, long welded rail, and the simply supported girders, there is an interaction between the two, due to which heavy forces are applied by the track onto the girder and vice versa. So this depends on the span length. So we cannot have very high lengths because the forces will become beyond control. So this is one criterion which we have to evaluate while we decide the optimal span length. So with all the studies for Hyderabad Metro, it was found that 31 meters was the optimal standard span. And segmental bridge span is constructed in segments. The box shape gives the torsional rigidity. Length, generally the pier segment is a shorter one because it has got a diaphragm inside, so it is a very heavy section. So it is shorter, it is width is lesser compared to the normal segments. And it all depends on the lifting capacity of the gantry. I've listed the various advantages of the segmental bridges. Long spans, it is economical, efficient use of materials, because pre-stressing material can be used in a very optimal manner. Then fast track construction, minimal traffic disruption, reduced environmental impact. These are some of the points. And box section, which I have already explained, what are the advantages having a box section: high torsional stiffness, efficient load distribution, reduced self-weight, and aesthetically it's a slim profile. Some metros, they use the inside space for utilities, for running cables and for running pipelines. How we have optimized the design, you can see here the different segments: S1, 2, 3, 4, 5, and again 4, 3, 2, 1. So S1, 2, 3, 4 is like a mirror image. S5 is a common segment, which is like a joker in playing cards. I will show you later the importance of S5. And each segment has got shear keys, which is very important because this will be useful for interlocking of the segments and transfer of shear and torsion. And they are given a trapezoidal shape so that they will be able to like a dovetail into the grooves which are made in the other segment. Then the shear keys are given more numbers in the flanges because webs carry more shear, so it is more in the webs. You can see them in the picture also compared to the flanges. The construction of segmental spans, there are 2-3 methods available: long line method and short line method. I will explain you before that how the standardizing of the spans is made. You can see here S1, 2, 3, 4, 5, again 6, 7, 8, 9, 10, 11, 12. 11. Now, if I have to increase the span, I can simply add one S5 segment, which makes it, earlier it was 28, it becomes 31. Similarly, by adding another S5 segment, I can make it 31 to 34 and 34 to 37. So this is the most important advantage of segmental construction, where we can standardize the span, and just by adding or removing one standard central segment, we can use the entire assembly for the different spans. Precasting is generally done by short line method. This is the casting yard. Short line method is generally adopted in the casting yards, but this requires a huge amount of geometric control because the viaduct will be curving both in the plan and in the vertical profile because of the vertical curves and horizontal curves. How it is done, I'll just show you in some sequence of segments. The first segment is cast as it is, and then it is moved to further location, and then it is rotated slightly to the degree which is required as per the actual alignment. And then the second cast segment is cast by keeping the first segment as the support for casting. And then the first segment is removed, and now second segment is slowly rotated to the extent required, and the third segment is cast. So this is how the casting is done, by controlling the geometry and giving the vertical profile during casting itself so that it will achieve this profile during launching. A small video on how the casting is. this is the principle of casting. This photograph showing the same thing. This is the match casting. That means the old segment, the casted segment, the new segment are cast side by side. They're stacking and cured. And for erection, we have a launching girder, a steel launching girder, which almost extends for 2 spans. And this is design and fabrication. There's a code for this. Load testing is also done before it is launched. The segments are transported. The launching girder lifts the segments, keep them in position, and then epoxy is applied between the segments. This is very important because epoxy acts as a lubricant when it is in the wet state. At the same time, it acts as a bonding agent and also moisture control during service. A temporary pre-stressing is done between the members so that the epoxy gets strengthened, and after that, the permanent pre-stress is done. The segments which are like this, finally after launching, it will be like this. So this is again another video which shows the launching. There is another method, balance cantilever method by launching the viaduct. This is used only at the special locations like road junctions where the span arrangement is much higher. This is the technique adopted for balance cantilever method by movable scaffolding system and pre-stressing of every addition of the concrete. But here the most important point is the geometry check. At every level, the geometry is to be checked because this is like a free cantilever which will be deflecting. So the deflection should be checked and monitored and properly adjusted and ensured that both the ends match perfectly. And at the end, we provided stitching concrete. That is how the balanced cantilever method of construction is done. The last part of my presentation is the station system. The station also is a very important structure in a metro system, because every 1 kilometer almost we have a station. So 70-kilometer track, 72 stations were there. And some of the technical optimization we have done here is standardizing the station design depending on the number of passengers. Then spine and wing concept has been adopted, which means precasting of all the elements and launching them, and ease of construction with minimum disturbance to the traffic. So this is the station concept, and all the modes of access to the station is provided: the staircases, escalators, and lifts. The stations have been categorized based on the traffic and also the ROW, and these stations have been standardized. So how the station has been constructed, I'll just explain to you. This is the interiors of the stations with all the modern facilities provided. The spine and wing concept, there's a single column which supports the platform as well as the concourse level. And all the elements except the pier arm is precast. So these are the station piers where the girders are launched, and then the pier arm, which is the only cast in situ item, is cast. And after that, all the precast elements are brought like spines and segments, and they are stressed and completed. And this is the one important point which I would like to mention is the lightweight bricks have been adopted to minimize the load on the columns for the internal walls. And the slabs and the beams for the platforms are also precast and launched by cranes. Entire staircase also is a precast system which has been brought to site and launched. The roofing system, which is very important because this is where the passengers are protected. It comprises of an arch-shaped PEB structure, very slim and sleek, at the same time very strong to take care of all the loads. And then a galvalume sheet is provided through purlin system. So these are some of the photographs during the construction. And the crane which is used is a mobile crane which is launched on the track, temporary track laid, and the members or various members are erected. There's a bracing system and the OHA fixtures which are fixed to the roofing system. The sheeting, as I said, comprises of the galvalume. When I talk about sheeting, these are some of the requirements of the sheeting system: economy and speed, structural and thermal performance, corrosion resistance, safety and sustainability. And in this context, I would like to mention the features which are available with optical manufactured by AM&NS. So optical system is, somebody would like to explain, please? Sridipal?
So we've launched Optical. AM&S India as a product has launched Optical last year. This is a product that is available in the market since last year, but it is already a patented product from Europe since the last 13 years. So it is research, well-backed product in the market globally. And this is the product that we've brought to India in order to cater to the roofing requirements. Now, this can be purchased by both individual home owners like you and me. And of course, as Sir rightly mentioned, this can be also installed on projects where these roofing requirements are critical. And these factors that rightly Sir explained of corrosion resistance, quick installation, all these are very important and play a vital role in all these projects. This is where optical can serve the purpose right. So what we are trying to do is we are trying to replace the galvalume that is available in the market with optical, because this has a composition of zinc, aluminum, and magnesium with a unique property of giving cut edge protection and corrosion resistance for a delayed period compared to what all products existing in the market. Right. So that is how the first slide explains the various applications of it. Now, this is what I rightly mentioned, that this is a substitute for the galvanized and galvalume product that is available in the market. And this is how we are replacing all the existing products as well. And we are trying to cater to this segment with the zinc, aluminum, and magnesium patented technology with Optical. What we have done is we have launched 4 variants under this particular product, which is the first is Optical Core, which is available with a 7-year warranty. And it offers ZM80 coating plus RMP paint system. Then we have Optical Pure, which is available with a 10 years warranty, ZM80 again, and SDP paint system. We have Optical Prime for harsh and even C3, C4 conditions. And this is available with SDP paint system and ZM120 coating. And then we have Optical Pinnacle, which is the highest performing variant, which can be suitable for all your coastal high pollution requirements as well. That's how we have categorized these products into different variants. this is what I rightly mentioned, that we can cover a wide range of applications with this product, from steel claddings, roofing panels, sandwich panels, architectural facades. This is what we are offering with this product, and I'm sure that this will be proved as a disruptor in this industry.
Thanks, Mr. Meet. So I strongly recommend this product because with so many good features are there. Yeah, I was just requesting all the audience and maybe strongly advising them to consider this product because it has got so many features, and because of the addition of magnesium, it has got corrosion resistance, because corrosion initiates at the ends where the cutting takes place, and where it's very difficult to maintain the material properties there. But because of this added elements, it has got better corrosion resistance, which is very important for massive structures, especially like metro roofs and station roofs. So I also would definitely consider this in all my future projects in railways and metros, not only because of these strong reasons, but mainly it is make in India, because galvalume we used to export. Thanks, Mr. Meet. And so I'll continue with the other my presentation. The final thing I would like to talk about is about the double-decker flyovers. Nowadays, it's becoming very popular. Nagpur recently has got 5 kilometers of double-decker flyover, and I myself have designed a double-decker but integral flyover. You can see at the road level, the girders as well as the pier arm, they got integrated, which optimizes the space, which reduces the vertical clearances. This is a model which has been generated, and in this model, we have done all the various load cases of IRC, load cases of metro, load combinations, and combination of combinations. To perform 3D analysis, construction stage, and RSA analysis. This is coming up in Trivandrum. There are 3 such flyovers which I have designed for Trivandrum Metro. Parapet is something which cannot be actually ignored because it has got so many features. We feel that parapet is only for just as a protection, but it has got other features, like it gives support for the cable racks. It gives support for the overhead mast structures, and even some substations can be supported on that. And in some metros, the parapets are used as an escape path. The parapets are cast in the yard and brought to the site, and a special gantry is used to launch them and then stitched in to the girder. This is the final stitched girder. So this is a completed viaduct, and some of the features which we have used in Hyderabad Metro during construction and after construction for maintenance purposes to minimize the resources, and O&M strategy which we have developed. This is the first test train. I was fortunate to be in the first test train as the head of the track system there. And this is the first commissioned train. So with that, I'm concluding my talk. I hope I'm in time. Thanks a lot for all the audience for your patient listening. If any questions are there, we can take.
Thank you, sir. There are some questions in the chat box. I'll just pick them one by one. So first is, elevated metro projects are often criticized for delays. What key process improvements could help ensure projects are delivered faster and more efficiently?
The most important point is planning. So we know the corridor in which the elevated metro is coming up. So the corridor, we have to see in advance, we have to visit it along with the stakeholders to see what type of construction can be best suited there, whether it will be full span construction or a segmental construction, U-trough, or boxed girder. So all this has to be done in the initial planning stage itself. So many times I've seen that proper planning is not being done, and straight away they go to the site and find a lot of obstructions, a lot of unwanted surprises, which causes delays and which causes public criticism also. So I suggest that a detailed planning has to be done, maybe at the DPR stage itself, so that all the risks can be identified, and also risk mitigation plan can be developed and incorporated, which the contractor will see and accordingly plan along with the stakeholders.
So there is another question. Could you highlight any case study from Bangalore, Hyderabad, or Surat metro projects where innovative solutions significantly improved the outcomes?
So whatever I have shown, they are all mostly innovative, because this was, especially Hyderabad Metro, it was the third metro at that time. I was talking about 2011-12. So many of the systems, like precasting of almost 25 units, right from box segments, then the parapets, then compound walls, staircase, the slabs for the platforms, the beams, and also the spines and wings for the station, all are precast, which is the first of its kind, and that has saved a lot of time and a lot of money also. That I will say is the most innovative concept which we have developed at that stage.
Sir, there's this question: how important is cross-disciplinary collaboration in ensuring the success of complex metro projects?
This is a very, very important point because cross-discipline collaboration, we also call it system integration. So there are so many interdependencies between the various systems which are to be properly identified by each system. There will be one coordinator who will be identifying what is his requirement from the systems. He will be sharing his requirements to the other systems. Similarly, the other system coordinators, in consultation with his teams, he will bring out the solution, whether it is possible or not possible, and come out with a combined solution which is acceptable to all. So this is this coordination meeting. We used to hold it almost on a weekly basis, so that the interdependencies and the intricacies are minimized during execution, and the works progress smoothly.
Sir, there are some young engineers in our audience, so I would like to ask this question. What advice would you give to young engineers aspiring to work in large-scale infrastructure projects?
Young engineers who want to work in large-scale infrastructure project, they have to develop the zeal. They have to have the passion to innovate, because whatever we have done, I don't say it is the best. Definitely there is scope for innovation. So I want them to see the entire project in their own perspective, in a different perspective, and see what best can be done or what improvements can be made in the system which we have not identified, and which makes the system maybe more efficient or less costly or faster. On the whole, it is going to benefit the society. So that is the most important thing which is required for the young engineers. The zeal should be there for innovation and for questioning. They should keep questioning everything, whichever doubt they are having. They should always question. They should always convince themselves that yes, it is correct. And if they feel that something is not correct, they should always give a solution. As I said, they should think and give a solution which can be adopted for the overall benefit.
So these were the questions. Thank you for such an incredible session and for taking us into the heart of metro innovation and showing us how engineering efficiency can redefine the mobility in our growing cities. Your insights into the elevated metro optimization reminds us that the infrastructure is not just about concrete and steel. It is about vision, innovation, and creating lasting impact for generations to come. To our participants, conversations like these are what smarter conversations stand for, bringing together experience, expertise, and ideas that inspire the action. We look forward to welcoming you again for the next chapter in this series as we continue to learn from leaders who shape the future of engineering, construction, and design. Until then, stay curious, stay inspired, and let's keep building smarter together. Thank you so much, sir, for joining.
Thanks once again, Ms. Muskan, and thank you, Mr. Dipal. Thanks the AMNS team for the opportunity, and thanks a lot for the audience for patiently listening for over 1 hour and asking some very interesting questions. Thank you very much.